Hello, today we are going to start our second day of substitution. All right, so let's look at this do now. Solve the following systems of equations. We already know what y equals. We know that when we solve a system of equations, we need an x and we need a y value. And so far, we already know that our y is -2. So we only have to work to find what x is. So let's look at the second equation, -4. We don't know what x is, so let's just put x -3, and then we know that our y is -2 equals 18. So now we have -4x, -3 times -2 is +6 equals 18. And now this is just a two-step equation. Subtract 6 from both sides. We get -4x equals 12. Divide by -4, and we get x equals -3. Before I commit to this answer, I just want to double check it. So -4, we know that x is -3, what we think it is, -3, and we definitely know that y is -2 because that was given to us. And we want to see, does that equal 18? -4 times -3 is 12. -3 times -2 is 6, and 6 plus 12 does equal 18. So check, we are correct. All right, let's look at the next question. I can find the solution of a system of equations by using the substitution method. Let's do it. Let's go over what the substitution method is. We want to make sure that one of the equations says x or y equals. We are going to plug one of the equations into the other to solve for one of the variables. Then we are going to plug the answer into one of the original equations to find the second variable. And then we will check our answer using the original equation. Most likely we would use the equation that we haven't used yet. So here is an example. Here we are told what y equals. That makes our life easier. Sometimes we might have to solve to find what y equals. So we would take out this y in this problem to replace it with 3x minus 9. And then we're just literally solving an equation. We have to combine some like terms. 2x plus 3x is 5x. Bring down the -9 and bring down the 11. To get rid of 9, we would add it. Then we divide by 5, and we find that x equals 4. Now, once we know what x equals, we can use either equation to find what y equals. But most likely, it's easiest to use the y equals equation, since it's already set up in that form. We just replace the x in the equation with 4, and we find that y equals 3. Now, when we want to go check it, we would use this equation, since we haven't really worked with this equation much. Then we would just plug in the values, and we would find that this is the answer. All right, so let's get started. Here, we are already told y equals, so we are going to replace this y with what y equals, which is 3x plus 1. So we would get 4. Instead of y, we're going to replace it with 3x plus 1 equals 12. We don't know what x is, plus 3. Good. Now let's do distributive property first. 4 times 3x is 12x. 4 times 1 is 4. Equals 12x plus 3. Let's subtract the 12x on both sides. Ooh, something weird's going to happen here. 12x minus 12x, that goes away, leaving me with 4. 12x minus 12x, that goes away, leaving me with 3. And 4 does not actually equal 3. That's false, meaning that we are going to have no solution. No solution. All right. Let's look at this next one. So, it is best to use the substitution method when one equation is already in the form x equals or y equals, because that allows you to know what the variable equals to substitute it into the other equation. If neither of these equations are solved for a variable, then you can just choose either equation to solve for either variable. It is best to solve for the variable in either equation that has a coefficient of 1 or -1. If you see an x is by itself or a y is by itself, or maybe you have like a -y or a -x, it would be easiest to rearrange the equation to get it to be x equals or y equals because you don't have to do dividing by an actual value. You would just have to move terms over and maybe at most divide by -1. So you'll see what we mean here. Here, if we look at this equation, none of them say x equals, none of them says y equals. So there's nothing we could substitute. So I'm going to go and look for which, because I have 2 x's and I have 2 y's, which one has a coefficient of 1 or -1. Might not always happen that way, but here, this one does have a coefficient of 1, meaning I'm going to get this equation to say y equals. So let's look at how I'm going to do this. I need to get rid of the 6x, so I'm going to add 6x to the other side. So that would leave me with y equals. You could write -11 plus 6x, but I just usually write the x first, so 6x minus 11. Good. Now we know what y equals, which is 6x minus 11, so we could replace y in the second equation since that's not the one that we rearranged. So that would give us -2x minus 3. Instead of y, we put parentheses, 6x minus 11 equals -7. So then we get -2x. -3 times 6x is -18x. And -3 times -11 is +33, which equals -7. Then -2x minus 18x is -20x, plus 33 equals -7. We're going to subtract 33 from both sides, giving us -20x equals -40. If we divide by -20, we would get x equals 2. Remember, that is not enough to get our answer because we also need to know what y equals. You could use this new equation that you made, but I like to use an original equation since I know those equations are like definitely correct. So I'm going to use this equation over here. Y minus 6x equals -11. And where I see x, I'm going to replace it with 2 that I just found. So I would get y minus 12 equals -11. Add 12 to both sides. Y equals 1. So I would have 2, 1. Let me make sure this is correct. Using the second equation, -2. Instead of x, I put the 2. Minus 3. Instead of y, I put 1. And I need to hope that this equals -7, which it does. So we are correct. All right, let's look at this next one. Solve the following system of equations. Make sure one of the equations is x or y equals. So I'm going to look and see if I have a coefficient of 1, which I do right here, so this would be easy. All I'd have to do is add 2y to both sides, giving me x equals 2y plus 11. Good. So now let's look at this first equation, because it's not the one that we rearranged. And anywhere where we see the x, we're going to put 2y plus 11. The reason why you substitute in is because we only know how to solve equations that have one variable. So we are working to get there to be only one variable. In this original top equation, we had an x and a y. But by finding what y equals from the second equation and replacing it in, we're able to get this new equation to only have one variable, which we are able to solve. -7 times 2y is -14y. -7 times 11 is -77. Minus 2y equals -13. Then -14y minus 2y is -16y. Minus 77 equals -13. Let's add 77 to both sides. That'll give me -16y equals 64. Divide by -16. Y equals -4. Good. And now I need to find what x equals. I could use either equation to find what x equals. I like to use an original equation. So I'll just use this one because it's on top. -7x minus 2. I found that y is -4 equals negative 13. Negative 7x. Negative 2 times negative 4 is positive 8 equals negative 13. Subtract 8. I get negative 7x equals negative 21. Divide by negative 7, x equals 3. Since I just plugged into the first equation, I'm going to use the second equation real quick to check. X is 3 minus 2. Y is negative 4. And does that equal 11? It does. So this is our final answer. X is 3 and y is negative 4. Beautiful. Good. It's a lot of steps, but it's nothing that you can't do as long as you go slow, stay organized, and stay consistent. All right, let's look at this word problem. The cost of a ticket to the cruise is $25 for children and $50 for adults. Okay, so children is 25 and adults is 50. On a certain day, the attendance is 2,000 and sales revenue is 70,000. How many children and adult tickets were bought? All right. The first thing I'm going to do is create an equation that has to do with money because I see 3 different numbers that have to do with money. I know that children tickets are $25, so I'm going to put 25C unless they told me to use a different variable. Plus the adults are $50. And I need to equal that to the other thing that has to do with money, which is 70,000. Good. Now, the next number I have is 2,000, which represents the number of tickets, the attendance. Who attended? The children and the adults. Not 25 children. That's not how many people attended. That's the price. We don't know how many children and adults bought tickets. That's what we're trying to find. So we will have no number there. I could choose to make this equation either C equals or A equals because they both have a coefficient of 1. I'm just going to make it C equals. It doesn't matter. So I'll subtract A. I will get C equals negative A plus 2,000. You could have also wrote 2,000 minus A, but I'm just used to writing the variable first. So I'm going to plug that into this equation. So 25, we found that C is negative A plus 2,000 plus 50A equals 70,000. So now let's distribute. 25 times negative A is negative 25A. 25 times 2,000 is 50,000 plus 50A equals 70,000. Then negative 25A plus 50A is 25A plus 50,000 equals the 70,000. I'm going to subtract 50,000 from both sides. And I will get 25A is equal to 20,000. Divide by 25. I get A equals 800, meaning 800 adults. Now, let's see how many children. I'll use the equation C plus A equals 2,000, where I'm going to replace my A with 800 equals 2,000. Subtract 800. And I'll get that the number of children that attended was 1,200, which makes sense because each adult can bring more than one child, which is why the number of children is more. And you're correct. At the circus, there was 800 adult and 1,200 children. Tickets. Perfect. Alrighty. let's look at this next one. It's an individual practice. Try pausing and seeing if you could figure it out. At least see if you can write the equations. The Science Museum charges $14 for adults. So 14 for adults plus 11 for children. Then it says the total bill for 68 people. So 68 total. That's not the number of price, so I'm not going to put it with my first equation. The price was $784. All right, so let me subtract C. I'm just going to get it A equals, since that's the first variable I see here. A equals negative C plus 68. And now let's plug into this top equation. 14, instead of A, I'm going to put negative C plus 68 plus 11C equals 784. 14 times negative C is negative 14C. 14 times 68 is 952 plus 11C equals 784. Negative 14C plus 11C is negative 3C plus 952 equals 784. Let me subtract 952, and I will get negative 3C equals negative 168 divided by the negative 3. We get C equals 56. So 56 children. Oh, and that's all the question asked for. All the question asked for was children. So we don't even need to do more work. I'll just show you if I was trying to find adults. I would do adults plus children equals 68. I know there's 56 children. Subtract 56. That means the adults were 12. Sometimes it's good to still find both, so then we could check using the first equation. 14, A we're thinking is 12, plus 11, and the C we got 56. Does that equal 784? It does. But really all we need to know here is that there were 656. Perfect. All right, and let's look at this little throwback question. What is a function? A function is when every input has exactly one output. Next question, what are the different ways a function can be represented? We could have ordered pairs. We could have graphs. We could have equations. We could have tables. Or we could have mapping diagrams. How do we tell if a graph is a function? We use the vertical line test, which says the vertical line can only go through the graph once. Now, to tell if a mapping diagram is a function, we need to make sure each input only maps to one output. And lastly, tables and a set of points are very similar in the fact that we just want to check that none of the x values can repeat. As long as none of the x values repeat, that means that every x would only have one y, which is the definition of a function. So let's see this all seen in a Regents question. Which relation is not a function? When a mapping diagram is not a function, that means one of the inputs goes to more than one output. Here, 1 only goes to A, 2 only goes to B, 3 only goes to C. That is a function. Here, A only goes to 3, B only goes to 4, and C only goes to 3. Every input is only going to one thing out, so that's a function. Here 2 goes to 12, 4 goes to 8, and 6 goes to 10. Everything is only going to one thing, so that is a function. But lastly, here 6 is going to 10 and it's going to 12, making it not a function. We cannot have an input that goes to more than one output. And lastly, which table represents a function means no x can repeat. The first one, I see 2 and 2 is repeating, not a function. Next one, 0 and 0 is repeating, not a function. Ooh, the next one looks good. And let's just see number 4. 0 is repeating, not a function. So 3 is a function because each x is unique. We have 3, 5, 7, and 9. I don't care about these output values. All right, that wraps up our lesson on substitution. Good job.